Hi all, welcome to my YouTube channel. So myself Rohit, I am an enterprise wireless engineer who already cleared gate twice and also other PSUs and other examinations. So I am here to share how we can study and achieve all the core things, like not only for clearing examination for and also for your college examination and your core placement. So everything I will be here to help you guys. So in this class, let's continue our understanding. So last two classes we have studied about the N type and P type separately. So in this class, let's begin the understanding of when both the different types of extrinsic semiconductor join together. Then let's take an example that it is an P type and this is an N type. So P type means how we will represent the negative will be inside and then extra holes will be mentioned outside. If it is an electron, that is N type, we will mention as a positive with another electron outside. So what will happen when both the thing is joined together? Because of some internal inbuilt electric field, the electrons from this side will move to this side, from the holes from this side will move this side from certain region of interaction, like in the small region here alone. So then what will happen is that there will be some separation will happen. So that thing we will call as a depletion layer. This is some separation will happen between both the two things. So this is what the separation layer will looks like. So here what will happen is that the holes from this side will be moved to this side. The electrons from here will be moved to this side. So here there is a movement. So then what will happen? The charge here will be neutralized by the holes when coming here. The holes here is neutralized by the electrons while coming here. Then this region there will be no majority charges, no minority charge carriers. So everything is neutralized and everything is in the stable condition. So this region we call as a depletion region. So at this instant x which is will be equal to 0. So we are mentioning something. So this is normal 300k. So everything we will take at the 300k for our understanding purposes. So whenever we apply forward bias, so forward bias is nothing but we are connecting a battery here. That plus terminal is connected to the P and the negative terminal is connected to N, because the charge is matched here, right? Because the holes is supplied here, then electrons is supplied here. So this is happen means then what will happen? More numbers of holes will come here and then it will be migrating here. So then what will happen? The extra holes will come here, then replaces here. So the absence of holes here, it is filled by the charge holes which is supplied by the batteries or any external supply. Then what will happen? Slowly the depletion region will decrease. Similar to here, slowly the depletion region will decrease, because the electrons will come and rectify this region or reduce this barrier. So then what will happen? The depletion width will get reduced, and not only completely it will occupy, then also the excess of holes which is coming here will be traversed from here to this region. Then what will happen? It will be completely traversed from here to here. The holes will go here, then electrons will completely traverse from here to here. Then this net movement is contributing a movement of the current. So then there will be a current production. The current production direction is in this direction, because that is will flow from P to N. Even if the electron go from the here to this direction, the current direction will be in this direction. So this will act as what? It will act as an conductor. So we can even state this as the on switch. Why we are stating the switch is that another one operation it will act as a off. So that is why we are making the term of switch. So here what happening is that we are supplying a battery, then current is going, so we are stating that is on. So the another one operation is the reverse bias. What we will do is that we will reversing the polarity. So the negative is applied to P and positive is applied to N. Then what will happen? More number of holes will come here. Then these electrons will also be neutralized by the holes. Then these holes will also be neutralized by electron. Then what will happen? The depletion width will increases. Then the I will be nothing, because no charge carrier will traverse from here to here. So the I will be approximately equal to 0. Why approximately we are using is that there will be some negligible current flow. That is every device it will happen, because everything is not ideal, right? So some kind of micro or nano amount of current will flow. So that's why we are making the approximation to 0. Then we can state this as a off switch, because there is no current flow. Even we connected a supply battery to the conductor or a semiconductor, the current is not flowing or movement is not happening. So we are stating this as a off. So a single material which is acting as both on and off. So we are saying this as a switch based upon the polarity or the supply we are producing. So this is what the one of the tremendous application of the PN junction diode. So this is what the diode will look like. So here we just see about the normal introduction. In the next coming lecture, we will see more about the things. In the last class, I have said when we increase the temperature, the extrinsic semiconductor will act as a normal intrinsic. So let's take an example that we are taking an N type. The temperature here it is, then it is an intrinsic carrier, like intrinsic carrier concentration, like N we are taking. This is the electron hole pair generation. It will be both N and P because equal number of hole pair generation only will happen. So at 300 K what will happen? We are considering the intrinsic carrier concentration to be 100. So 10 electron hole pair concentration is producing for N and for P. So this is for N and this is for P. So here this is N because we are taking N type. So here what will happen? The N is much greater than P because N total count is 110 but P's total count is 10. So this is act as a N type only. Here there is no difference. So let's take a 400 Kelvin. Here what's happening? The same material we are supplying the increasing the temperature. So here what's happening? Some 1000 carriers are produced because of the increasing temperature. The same 1000 carriers will produce for P. So here also what's happening is the 1100. So it here also what's happening? It's acting as a P type. So N is greater than this one. So here also it's an N type. So if we go to 500 Kelvin, then what will happen is the intrinsic is 100, but here there is 1 lakh electron holes pair are generated. So comparing to this, the N will be approximately equal to P. So here this is why we are stating this as a intrinsic semiconductor. So even at the higher temperature, the extrinsic semiconductor will act as a intrinsic semiconductor. So that's why we are stated that when we increase the temperature, the intrinsic semiconductor will also become as a extrinsic semiconductor will also behave as an intrinsic. So this is one of the major application because if we keep on increasing the temperature, then we will not be getting the benefits of the extrinsic semiconductor or individual hole pair generation. So that's why we are trying to state here that when we increase the temperature, the material behavior will be changed to intrinsic semiconductor. So I hope this is very clear for you. So if you guys have any doubts, please ping in the comment section. So sure I will rectify those doubts.